Hello, welcome to COSE441 Internet Protocols. My name is Hyogon Kim. I'm the instructor for the course. Mr. Youngjun Yoon will be my TA, and here are our phone numbers, the office locations, and our email addresses. The office hours are Wednesdays 10:30 to 11:30 a.m. So you can come to my office if you have any questions or requests to make. But in case you cannot make it, because you have time conflicts with something else, then you can try to set up an appointment with me. You can send an email to me for that matter. And we don't really have a textbook for the course, but there's a reference. It's TCP/IP Illustrated Volume 1, written by Stevenson Fall. It's from Addison Wesley. Okay, and the assessment. It's basically sum of three numbers. The first one is midterm, which accounts for 40% of your grade, quiz 10%, and final 50%. But in case we cannot have the quiz exam for some reason, the percentage of the midterm will rise to 50%. We have a course homepage. It's widen.korea.ac.kr. If you go there, you'll find several tabs. One of the tabs is courses. If you click on it, you will get to a page that has a list of courses that I have taught and that I'm teaching this semester. And one of them is COSE441. Because I make announcements there, important announcements, and also because I put up important resources, it's recommended that you check the homepage regularly. In particular, I put up past exam problems just before midterm and final exam. Okay, now we can start. Let's first try to understand the title of the course. It's Internet Protocols. So what is Internet? What are protocols and what are Internet protocols? Okay, first of all, Internet. Internet is actually a combination of two words, inter and net. And inter etymologically means between. So if you see this word inter as a prefix, it means that it describes something that happens between things. Okay. So internet, well, when you say internet, it's something that happens between networks, obviously. And in particular, for internet protocols, we mean possibly incompatible networks by this net here. So there are many communication or networking technologies that you use today. For instance, Ethernet, Wi-Fi, and 5G cellular. Unfortunately, these technologies cannot talk to each other. They are totally different beasts. And if your friend is connected to an Ethernet segment, and you are connected to 5G cellular networks, in principle, your friend and you, basically your friend's computer and your computer, cannot talk to each other. But somehow, we can do it now, okay, today. So that's the magic, and that's what internet protocols do. Okay, so today we have a global network of networks, which is the internet. And throughout the semester, we will see how the magic is done. Okay, so to make the internet the single thing, a single network of networks, what we have to do is to overcome the barrier between networks, because they're incompatible, they don't talk to each other. And then we weave a global network out of these incompatible things. You can think about two solutions. The first solution, potential solution, is making translators between all possible pairs of different technologies. So, if your friend sends something to you, and if your friend is connected to Wi-Fi, then probably that data has to be transferred from the Wi-Fi network to 5G network that you're on. So where these two incompatible technologies meet, you put a translator there that translates between Wi-Fi and 5G, right? But creating these translators for all possible pairs of different technologies is not scalable. It has order of n square complexity, where n is the number of incompatible technologies, right? So if somebody develops a new fancy technology, communication technology, then it means, under this scheme, it means that you have to develop n order of n translators, right? Well, we cannot do that. It's infeasible. So there's an alternative, which is develop a common language or common thing that you can translate into. So, for instance, your Wi-Fi can give the data from your friend to this common thing, and you on the 5G network side can translate back the data into 5G format. Okay, so that common thing, if you have such common thing, then you solve the scalability problem. You mitigate the problem, because you don't have to have order of n square translators. You just need order of n translations. And this common thing is called the Internet Protocol. Okay, so when two incompatible networks meet, what they do is to translate their data into IP format, and then translate the IP format into the second incompatible technology. That's how the internet connects these incompatible networks together. Let's take an analogy here. Trans-Siberian Line, Trans-Siberian Railway, connects Moscow to Vladivostok or Beijing. Unfortunately, there's a problem, because the railway systems differ from country to country. Russia and Mongolia and Finland use so-called wide gauge. The distance between two rails in wide gauge system is wider than so-called the standard gauge. Okay, standard gauge is international standard. China, Korea, and many other countries use standard gauge. Since the train that runs from Moscow to China has to cross the border, something should happen on the border, because the train running on Russia's side has wider gap between two wheels. In China, it's narrower, so you cannot run the train across the border between Mongolia and China. So what happens is that when you arrive at the border, this is what happens. In this picture, the cabin is lifted up by this machine, leaving the wheel unit below on the ground. This wheel unit is called a bogie. So bogie is detached from the cabin, and actually it's pushed away. And then a new wheel unit is brought in, but this wheel unit is on the standard track. standard gauge. How is it possible? If you carefully examine this picture, you can see there are 3 rails. Okay, so the rail in the middle and the rail on the top, the distance between them is standard gauge. But the rail, the leftmost one, and that one, the distance between these 2 extreme rails, they have wide gauge distance. So this unit, the old unit that was pushed away, was on the wide gauge tracks, whereas this standard gauge bogie is on the standard gauge rails. And when that's done, the cabin is again put on the bogie, and now the train is ready to run on Chinese tracks. Okay, so there is this technology change on the border, and that's exactly what happens in the internet. And the special facility that we saw earlier here in internet, it's called a router. So in the router, okay, on one side it uses one technology here, it's Ethernet in this case, and on the other side it's another technology. Okay, so it's 5G, for instance. What happens is that your data is brought in on Ethernet technology. Okay, the Ethernet carries your data, and the data part, which we call IP datagram, is detached from Ethernet frame or Ethernet format. It's detached. The data is moved onto this side, and it's put on the 5G data format, and it's moved away in this direction. So that's how the router overcomes the incompatibility problem between Ethernet and 5G. And this happens every time 2 different technologies meet. Okay, by doing this, IP can accommodate any technology. Okay, so there is this saying, IP runs on everything. So this is the magic that we perform in the internet. And actually we have to perform this magic many times from one computer to another computer, because internet connects machines all over the machines all over the world. Okay, so the internet works like a bucket brigade. So suppose your data is here and your friend is here, and what happens is that these people here represent routers. The routers move your data in this common format, which is IP datagram. So they move your IP datagram to your friend.